Okay, so in this video we're going to look at the LCM, which is the lowest common multiple, and we're going to do it for the numbers 12 and 90. And just like with the highest common factor, we're going to do three different methods. We're going to do a listing method, a table method, and then a prime factors method. Now, the listing one kind of gives us really what the definition actually is. We're going to list the multiples of 12 and 90. We're going to see which ones they have in common, meaning they both have it, and then we're just going to pick the lowest one. So first of all, I'm going to start writing down the multiples. I'm actually going to write down the multiples of 90 because it's bigger. So I'm going to write down the 90 times table. So I'm going to go 90, 180, 270, and I'm probably going to stop there actually because I'm hoping that there'll be a multiple of 12 that will be one of these. So we're going to do the 12 times table. 12, 24, 36, 48, 60, 72, 84, 96, 108, 120, 132, 144, 156, 168, and then eventually 180. So you can see why the listing method isn't always going to be that good, because it can sometimes take a really long time to get to that lowest common multiple. But the multiple that they have in common is 180, and that's going to be the lowest one because it's actually the only one that we've got in common out of this list. If we kept going, you might want to think to yourself what the next one they would have in common, and actually if you did this next one here, it would be 360. Eventually this list would also get to 360 as well. However, it would not be the lowest one, and we're just looking for the lowest common multiple here. So that's the first method, listing. It's very easy to make a mistake when you're doing the 12 times table. It might not even be numbers like 12, it could be bigger numbers. So that's probably why I don't like listing very much. I think sometimes it's easy to go wrong there. But I'm going to use the table method, which is exactly the same as the highest common factor, apart from the last step that you do. So with the table method, when we did the highest common factor, same thing that we're going to do here. We're just going to try and fill in the numbers in the side part and in this middle section by thinking, what are 12 and 90 both divisible by? Well, they are both in the 2 times table. So I'll put 2 over here, and I'll do the 12 divided by 2 to get 6, and the 90 divided by 2, which is 45. Now we need to look at these two numbers, the 6 and the 45, and think, what times table are they both in? They can both be divided by 3. They're in the 3 times table. 6 divided by 3 is 2, and 45 divided by 3 is 15. Now, when we get to this stage with 2 and 15, there is no number that they have in common as a factor other than 1. But if you did 1, like I said before, you just keep ending up with the same thing. So we don't use 1. We're just going to stop at this stage. Now, previously, you'll remember that the highest common factor was these two multiplied together. But now the lowest common multiple is going to be these ones all multiplied together. And what you'll see is it actually creates kind of like an L shape. If you only have one number here, it would obviously just be like the bottom section, but it's going to be the same as the highest common factor and also these ones. So it's the LCM from the table. So the lowest common multiple is going to be equal to 2 times 3 times 2 times 15. 2 times 3 is 6, and 2 times 15 is 30. So 6 times 3, add on the 0, the lowest common multiple, just like we had on this one here. I guess I should have said the lowest common multiple is 180. We've shown that we get the same answer for both of these questions. So it's that L shape for the lowest common multiple. Now we're going to have a look at the prime factors method. Now the prime factors method, previously when it was the highest common factor, we said it was what loses. But with the lowest common multiple, it's going to be what wins. In other words, what are the highest powers that we've got? And the way I like to remember this is highest, we normally think would go with wins, and lowest with lose. But they're kind of like the other way around. It's kind of like they've switched places, like the lowest you thought would go with losers, but it goes with wins. So it kind of is the opposite of what you might think. So let's have a look at what I mean by prime factors for like what loses, and actually it shouldn't say what loses, should it? It should say what wins here. So it's going to be what wins, and the highest power is the one that wins. So let me just very quickly change that. And we're going to do the prime factor decomposition for 12 and 90. Well, 12 is really easy. 12 is just 2 squared multiplied by 3. 90, I'm just going to remind us we can do this on the calculator. So you type in 90, press equals, then shift fact. That is 2 times 3 squared times 5. So we're now going to look at each of these sections and decide what the winning part would be. Well, for this first section that we've got, out of 2 squared and 2, the highest power, I don't know why I'm saying highest common factor, because we're doing the lowest common multiple. The highest power that we have of 2 squared and 2 is 2 squared. And the highest power out of 3 and 3 squared is 3 squared. And then the highest power out of these ones, well, we've got 5 or nothing, so the highest one is 5. So the lowest common multiple is 2 squared times 3 squared times 5. That's going to be 4 multiplied by 9 multiplied by 5. 4 times 9 is 36, and 36 times 5 is also 180 that we've got there. So if this was the highest common factor, just as a recap to the last video, the highest common factor is where you would pick the lowest power. So the lowest power would be 2, the lowest power here would be 3, and the lowest power here would be nothing. The highest common factor would be 2 times 3, which is 6, which was the same as what we would see as the highest common factor here, 2 times 3 being 6. I'll just pop this bit in brackets here, as it's not really related to what I was asking about. Okay, so in the next video, I'm going to do these with some examples. I'm going to do these ones here, and then you can have a go in the next video at doing these ones. Found this video helpful? Then why not drop it a like and consider subscribing to my channel. If you'd like the next video in the playlist, you can click here to be taken straight to it. And as always, wishing you the very best for all your studies.